Hi, the purpose of this video is to introduce you to the LTSpice software. LTSpice is a circuit simulation software very widely used throughout industry, and we're going to see how to use it to simulate simple circuits, including some of the ones that we have already looked at in class. So the LTSpice software can be downloaded here from the Analog Devices website. There's a link on the Moodle. Get here and download the version that is appropriate for your machine. Install. When you first run it, it's probably going to ask for some updates. It takes a little bit of time, but then once it's up and running, you can start the software. So when you start LTSpice, you get this screen. It's a bit of an old-fashioned looking piece of software. Under the hood, it's very powerful simulation software, but I guess they've not really worked on the interface for a few years. So it kind of has a bit of a antique feel, and this picture that looks like a coffee blot for the background. So there's a toolbar at the top. First item on the toolbar is to create any new schematic. So I'm going to click on there. You can also look at the menu to launch that. So new schematic, you're going to get a blank screen. I have changed some of the color and style settings on my version from the defaults, so mine might look a little bit different in terms of colors and line thicknesses and stuff. If you're interested in changing any of those things, you can go to the control panel, which is right here. And a whole load of different options for you to change. Drafting options here. Has all that kind of stuff about the color scheme, etc. You don't have to change it, but you can if you want. One thing I would strongly suggest that you do change is this option here, automatically scroll the view. When you first install that, defaults to on. There's a check mark in here. I would suggest taking that check mark off. It's kind of a really irritating feature, I find. Basically, as you move to the edge of the screen, your image scrolls, which means every time you go up to the toolbar to grab a tool, you move your image. I don't know, maybe it's easier to do that when you have a very large schematic, but I just kind of find it annoying, so I would click that one off. Other than that, there's nothing else on the control panel that we need to look at. There's some tools up here about simulation, which we'll come to later, and I'll cover the rest of the tools. But I want to get straight into building a circuit, and to do that, I need these tools, which are over on the right-hand sort of half of the toolbar. And I'm going to make a simple circuit with just a voltage source and a resistor to begin with. Okay, so to put a resistor in, we go up to here. There are buttons for resistors, capacitors, inductors, diodes, and other components. We're going to start with a resistor. I'm going to place it here. You click and then move to where you want it. You click again to drop it. As soon as you kind of stay in this resistor dropping mode, so if you want to do something else, you have to kind of get rid of that. You can go press escape. It takes you back to just the cursor mode. A couple of things you can do with the resistor. You can set its value first. So it has a name R1, it has a value R. If you move over, right click, you get this little box. You can change its resistance right here. So I'm going to make this 120 ohms. The system knows about all the standard like order of magnitude prefixes, so you can put K and make it 120,000 ohms. You can put M and make it 120 milliohms. One to watch is mega ohms. You have to actually type meg. Micro, instead of the Greek micro symbol, you just type the letter U, which looks a bit like micro. This resistor is going to be 120 straight on. So Let's hit OK. The value changes right here. And there's also a name. If you want, you can change the name of the resistor. This is the one that is given automatically. I'm just going to leave that one the same. But if you want to click it, you right click and you can change the text right there. Okay, so let's put in a voltage source now. Voltage sources are under component. So if you click component, you'll see there's a whole bunch of different components available. Just to click on a couple of them. There's various different capacitors. There's LEDs. There's transistors. There are literally hundreds, thousands of different components to look at here. We're going to choose voltage. If you're searching for a particular component, you can type its name into the search bar, which is just there. We're going to take voltage, and that gives us a basic voltage source. And put it on the other side. Again, I just click once to drop it. Press escape to go back to the cursor. If you do accidentally put something down, like if you accidentally put another resistor down you didn't mean to, you can remove them easily with the little scissors. Click one of the scissors on them and make them go away. Okay, so the voltage source, again, we can set its value. So right click, that gives us this little box. We've got the DC voltage value. I'm going to make it 5 volts. There are some advanced options as well. I'll just quickly show you where you can make it, instead of a DC voltage, you can make it a sine voltage, a voltage that varies with time. We just want a basic DC voltage for this circuit. Okay, again, you can, if you want, change the name of the voltage source. I'm going to leave it as it is for the moment. So what I want to do is connect these two components with wires. So I use the little pencil tool up here, and the cursor changes into these two lines. Click, 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 and click. You'll notice as you draw, the lines are confined to a grid. Everything kind of is lined up to a grid. You can't draw diagonal lines or anything. It's only straight lines. So click, 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 and click. And you see I'm drawing to the little red square, or the little square that represents the terminal of the dies. Okay. Again, if you decide the line wasn't the way you wanted it, you can use the cut to get rid of lines and draw them again. Okay. So again, escape takes us back to just the cursor. Okay, so we're almost ready to simulate this circuit. You can just, if you want, use LTSpice to draw circuits. It can be useful for drawing circuits for reports, etc. However, its real power is in simulating what's actually going to happen in the circuit, and it can do all kinds of different simulation. I'm just going to zoom out a little bit so that it looks a bit smaller. One thing that we need to do in order to do the simulation is we do need to put in a ground connection. Now, you can build a circuit like this with just a battery as your voltage source and a resistor and not connect it to ground, and the thing will run fine. The physics of this doesn't require a ground connection, but the actual simulation itself requires you to define at least one point in the circuit to be 0 volts that everything else can be measured in reference to. So we do that with this little button here. The little down arrow specifies ground. I can click. I usually like to put a little bit below like that, and then put a wire to connect it from the little connection to that wire. It makes a junction. And now actually, if you hover over anything that is connected to this ground connection, and you look, and you look down here in the bottom left-hand corner, you'll see as I hover over it, says this is ground, it says this is ground, this is ground, it tells you this is ground. If you hover over this other wire, you'll see that it says this is node N001. More about that in a moment, but every wire that you connect within LTSpice is what's called a node or a net, and it's given a unique name, which you can change, but we'll talk about that in a moment. What we're going to do now is simulate this and see what we actually get. Obviously, you could work out from Ohm's law what the current through this resistor would be. We're going to get LTSpice to do it for us. Okay. So what we want to do is go over to the running man icon to run the simulation. Now, we've not told it yet what kind of simulation we wanted to do, and LTSpice can do lots of different simulations. And we'll go through most of these at some point. Transient analysis kind of takes the real time of the circuit immediately after you turn it on and sees how it all changes through time. There's AC analysis, noise analysis, all kinds of things. For the moment, we're just going to do this, DC op or operating point. So this is just going to literally work out what the steady state voltage and currents are around this DC circuit. Now, one thing I want to point out is this little thing down here that says .op. We'll come back to that in a moment. I'm going to press OK. And it puts up this result of the simulation. And basically what the simulation is going to tell you is the voltage in every node and the current through every component. So we have here the voltage of net N001, which if you remember is this line here, which obviously is at the voltage of the top of the power supply. It doesn't tell you ground, it's 0. And then it tells you the current through I1 and the current through B1. That current is 0.041667 amps. You can check that with Ohm's law. It also tells you the current through the actual power supply, which of course is the same but negative. Sometimes it's not always obvious why the current appears negative. Generally, we're only interested in the magnitude of the current. Direction is usually kind of obvious from the context. So don't pay too much mind to the sign of the current for most of these simulations. The main thing is the current value. Okay, if I close that for a moment, you'll see now if I hover over these, it actually has the simulation values in. So now it says this is node N001, and the DC operating point is 5 volts. And if I hover over the resistor, it tells me what the current through it is and the dissipation of it is. And this is just showing me the values from the last time the simulation was run. As you get more nodes in, it's sometimes kind of gets confusing which node is which, because they were given these kind of meaningless names. So for important bits of wire, you want to give them a name. This is our sort of main power source. I'm going to give this a name. So I'm going to click on this bit that says label net. It's this little A symbol. I'm going to call that line VCC, which is a common name to give the power line or the voltage power line in a electronic circuit. I'm going to keep port type of none. And basically what I have to do is drag this label to the wire, putting its little this little connection point onto the wire. And that's now labeled VCC. And if I run the simulation again, now you'll see that has that name, and it can just be a little clearer when you're doing more complicated simulations to name the nets, so that you kind of, when you read this report, then there's like a dozen different voltages, you know which one is the one you're interested in. Okay, so this is kind of a bit of a boring simulation, so let's make it a bit more interesting, put some more components on. So I'm going to put 2 more resistors. Put one there. I'm going to put the next one up here, but I actually want it to be horizontal instead of vertical. You can do that quite easily by pressing Ctrl R to rotate it. And you can also go up to the toolbar here where there's a rotate button. Okay, so we'll put that up there. We will connect it again. Connecting round. And now if we hover over, you see this is still ground because it's connected to the ground connection. This new piece of wire I put up here is VCC. This new piece from R3 to R2 is a new node. It's called this one N001 now. Probably wouldn't bother renaming that one because it's not necessarily a useful node unless it is. So let's give these some values. So I'm going to make this one be 120. I'm going to make this one 220. Okay. Now, one thing is the simulation is now wrong, although it says like a current through this. That current was for the previous run of the calculation. Again, I'm looking down to the bottom left-hand corner of the screen where it shows the current through the component I'm hovered over. That's going to be wrong because I've now put these resistors here and this calculation was done without those resistors here. So we have to run the simulation again. And now it's giving us all the different currents that we're expecting. 2 and 3 obviously have the same current as you'd expect. R1 has a different current. This new little wire here is at a different voltage than 5 volts now. And we have all the parts of the calculation done. Okay, so what I'd like you to do now is to look back at the Moodle, and you'll see after this video there's a little activity to do, just modeling the circuit that we had in the homework, and see if you get the currents that that you got from using Kirchhoff's laws using the LTSpice simulation. Have a go at that, and then we'll look at a little bit more of some involved examples using LTSpice. Okay, thank you.